Hello everyone, thank you for joining me today. In this video, I will show you my new Fluke 107 600 volt Cat3 digital multimeter. I bought this one from Amazon.com and it came in just this plastic pouch. There is no separate box for it, and I think that's the reason why the retail box of the Fluke 107 was a bit destroyed at the bottom part when it arrived to me. However, the contents of the retail box are complete. This is the unit itself, the Fluke 107, the magnetic strap and stand, and Chinese quick user's guide. This is the safety information booklet in various languages. It includes the specifications of the product, but there is actually no instruction here. I really find it strange that the English user's manual is not included. This is not a user's manual, but just safety information in various languages. So I'm a bit disappointed that the English user's manual is not included. I think the user's guide sheet like this one is actually the how-to or the instruction manual of the instrument. Unfortunately, it is in Chinese and printed in very small fonts. I think I have to download the manual of this instrument from their website to get the English version of the user's manual. At the back of the retail box, we can find a listing of the basic specifications of the product. You can pause the video to look at this in detail. This particular unit was made in China. The box contents listing. On the front, we can find the basic features of the Fluke 107 in various languages. Category 3, 600 volts. Here is the main unit, the Fluke 107. It still has the plastic protective covering on the screen. But the first thing I want to do is to check whether the batteries are intact or if they are leaking, because the batteries were already installed in the instrument upon delivery. The nice thing about this battery lock cover is that it uses a plastic latch instead of a metallic screw. I actually prefer a plastic latch or a plastic locking mechanism like this one. So that's the battery compartment cover, and this is the battery compartment. Removing the batteries, it is powered by two AAA alkaline batteries, and as you can see, there's the sticker for the calibration seal. These are Energizer Max alkaline batteries. They look clean, so that's a good sign. The expiration date says December 2032, so these are fresh alkaline batteries, so that's good. Examining the battery terminal posts, I can see that they are also clean, no sign of rust or battery leakage or any kind of corrosion, so this is good. There is a sign for the lock and unlock symbols there. Just align the locked symbol to the arrow, and the battery compartment cover is already closed and locked. I like that it is very small and handy. It has 3 input terminals, the black for the common terminal, the rightmost one for the V, the resistance, capacitance and diode, test lead, and the third terminal on the leftmost side the A or the current input terminal protected by a 10 ampere fuse. So that's the ammeter function of the Fluke 107. So the Fluke 107's function selector goes from off to the AC voltage function. It makes an assured click into position. That's the DC voltage measurement function, millivolt AC, and a combination of resistance, continuity, and diode function in one selector dial position, capacitance, and AC and DC, auto AC and DC current measurement function. We have the data hold button to hold the value on the screen, the frequency and duty cycle, the select button to toggle these functions, and this is the backlight button. Now, I understand that not all Fluke multimeters have a backlight button. For example, the Fluke 101 and 106 do not have backlight button. But I appreciate the fact that when Fluke does include a backlight on their multimeters, they seem to be consistent in the fact that they put a separate and dedicated backlight button for it, like here in the Fluke 107. One other manufacturer that I know who puts a separate dedicated backlight button on their digital multimeters is Hioki. Maybe there are other manufacturers out there that implements this kind of design, so props to them too. Having a separate button for it is so much more user-friendly for electrical practitioners. The Fluke 107 also has a unique feature that is not even available in their other multimeters like my Fluke 116 or 115, and that is to simultaneously disable the auto power off and disable the auto turn off of the backlight using these two buttons. To disable the backlight timer, press the backlight button and turn on the device. L-off means that you have already disabled the timer for the backlight. So anytime you turn on the backlight, it will continuously light up the screen until you manually turn it off. To disable the auto power off of the device itself, press the yellow button and turn on the device. POff means that you have disabled the auto power off function of the 107, and it will continue to power on the device until you manually turn it off or until the battery runs out. But the unique feature of the 107 that is not even found in the Fluke 116 or 115 or even 117 is that you can simultaneously use those two power-up options. Press and hold the backlight button and the yellow button at the same time and turn on the device. L-off and P-off flashes on the screen. That means that you have simultaneously disabled the auto power off of the device and disabled the timer for the auto turn off of the backlight. Now, since I mentioned the Fluke 116, 115, and 117, I have here the Fluke 116. The Fluke 116 can actually also disable the auto turn off of the backlight by a power up option, the same as the Fluke 107. Just press the backlight button, and now the auto turn off of the backlight is disabled. To also disable the auto power off of the 116, press the yellow button and turn on the device. P-off also shows up, which means that the auto turn off of the power to the device is also disabled. What it cannot do is to simultaneously use those two power-up options. It can only select either the auto turn off of the backlight's timer or the auto turn off of the device's power. The Fluke 107, however, can do those power-up options one at a time or both at the same time. So that's what makes the Fluke 107 unique among the Fluke 100 series and Fluke 110 series of digital multimeters, in my opinion. This is the magnetic hanger and magnetic stand of the Fluke 107, and this is the problem with not having the user's manual included, because now I have to do a trial and error to get this right. Apparently this slot here is for strapping this magnetic hanger and stand. So maybe that's how it is being used. I'm not really sure if this is the correct way to use it, but it seems to be working. The Fluke's smart magnetic stand and hanger actually looks kind of elegant. I don't think it will cause the instrument to topple easily, since the instrument is very lightweight anyway. So that's the smart magnetic hanger and stand. This is the TL75 test leads. I have several pairs of these test leads from my other Fluke digital multimeters and clamp meters, so I'm quite familiar already with this kind of test leads. The Fluke 107 is quite tricky to be opened, but this is now the internals of the Fluke 107. Now, I do not claim to be an expert on electronics or multimeters, but from what I'm seeing here, I could see that the design of the electronic components and the microprocessor of the Fluke 107 is very well made. And I should note though that the fuse protecting the input of the current terminal is rated at 1000 volts with a steady state ampere rating of 11 amperes. And if I'm not mistaken, I've seen this kind of fuse before. The interrupting capacity of this is 20,000 amperes. I've tried removing this fuse, but it's very hard to remove it, so I'll just leave it there and try not to force it unless it's really necessary for me to replace it. But for now, I would just say that this multimeter has a very good fuse protection. 1000 volt fast acting fuse or high rupturing capacity fuse, 11 amperes steady state current protection with 20,000 amperes of fault duty or short circuit current interrupting capacity. This is a 230 volt rated AC outlet. The Fluke 107 reads 232.4 volts AC. Frequency 59.8 Hz. Duty cycle 49.9%. And back to 233 volts AC. By the way, some of you might be wondering why my function selector has a white strip over there. Originally that white strip was absent, but I like to improve the visibility of my function selector dial, so I placed a strip of white sticker there, and it looks much better now. .38 volts for this 9-volt battery. 3.9 volts DC for this 18650 lithium battery, and for this AC-DC power supply adapter, minus 12.32 reverse polarity, 12.33 volts DC. These are the terminal connections for my Bosca solar panel and Bosca solar light. I'm now going to measure the charging voltage, the DC charging voltage. I've set the instrument to measure DC voltage. At this time, the DC charging voltage is 4.556 volts DC. I will now try and measure the charging current of the solar panel going to the solar light's battery. For current measurements, these connections are very, very important since we need to connect the multimeter in series with the load. The red test lead goes to the current input terminal or the A input terminal, while the black test lead stays at the COM terminal. The function selector must be selecting the current measurement function. I can select either AC or DC current there, but since I'm measuring DC current, I will select the DC current measurement function. I will now connect the multimeter in series with the load. The multimeter is now connected in series with the load, and it is registering 1.24 amperes DC. So that's the current being delivered by the solar panel to the solar light's battery. As a safety reminder, after making any current measurement, remove the test leads from the test point, remove the test leads from the input terminals, and turn off the device. In this manner, if your next measurement is a voltage measurement, you are not likely to make a wrong input terminal connections, because the correct input terminal connection for voltage is that the black test lead goes to the COM terminal and the red test lead goes to the V terminal. Now the LCD screen of the Fluke 107 is big, and the characters are also bold. They are very clear, the contrast is good, and when viewed slightly at an angle from below, this is, I think, the best viewing angle. When viewed from the side, you can still read the characters well, but when viewed from the top, the characters wash out. You cannot do anything about it. So the best viewing angle for the Fluke 107 is viewing it slightly below 90 degrees. Ten ohms, 99.7 ohms, 0.458 kilo ohms or 460 ohms, 9.82 kilo ohms, 66.5 kilo ohms, and 0.68 mega ohms or 680 kilo ohms. Let's test for diodes. The test voltage for diode of the Fluke 107 is only 2 volts DC with an accuracy of 10%, 0.498 volts, 1.703, 0.549, 0.169 volts. These capacitors have a rating of 4.7 microfarad, 1 microfarad, and 100 microfarads respectively. One point, 4.9 microfarad, 1.047 microfarad, 109.1 microfarad. Let's test for continuity. The Fluke 107 makes two kinds of beeps in its continuity test. So the continuity of the Fluke 107 works, and its speed is just fine for me, for my purposes. But maybe for some of you, this speed is not fast enough. One other advantage of the Fluke 107 is that it is compatible with this AC clamp accessory called Fluke i400E, which is capable of measuring up to 400 amperes of current. And this is possible because, first of all, the terminals of the Fluke i400E is a perfect match for the input terminals of the Fluke 107. By placing the function selector to the millivolt AC voltage and connecting the Fluke i400E, current can be measured up to 400 amperes. And this is because the conversion ratio of the Fluke i400E is 1 millivolt AC per ampere of current. So any reading on the screen of the Fluke 107 when used with the Fluke i400E on its millivolt AC range corresponds to the actual current being measured. Also, the range of the millivolt AC of the Fluke 107 is up to 600 millivolts. So essentially, it can handle up to 600 amperes of current. However, the Fluke i400E is limited only to 400 amperes of current. Here are the things that I really liked about the Fluke 107. It is small, lightweight, and very, very compact. It is simple to use. with only the basic functions included. It has a separate backlight button and also those two unique features that I mentioned before. I like the fact that it is protected by a high quality fuse rated at 11 amperes steady state current with a fault duty or short circuit interrupting capacity of 20,000 amperes, a high rupturing capacity. I also like the fact that it included this smart strap and hanger. It is rated category 3, 600 volts with a fuse protection of 10 amperes. And the Fluke 107 is also compatible with the Fluke i400D AC clamp accessory, which means that it can be used to measure AC current up to 400 amperes using this AC clamp accessory. Now, some of the things that I'm not very excited about is that the included documentation of the Fluke 107 is a safety information booklet with a lot of language versions. While the safety information is useful, I'd much prefer also that they included a printed user's manual. Unfortunately, the printed user's manual is not included in this retail package. I also find it quite difficult to access the fuse inside the multimeter because the metallic screw holding the back of the meter, they are quite tight and it's very, very difficult to remove them unless you use quite a bit of force. So there might be a danger of destroying the plastic connections of this metallic screw in trying to access the fuse in case you need to replace it. The continuity function of the Fluke 107 is not as fast as you would expect it, so that might be a concern for some users. And last but not the least, this Fluke 107 sells for around $97 from Amazon, and I believe that for half the price or less the price of Fluke 107, you might find other branded or other brands of digital multimeters which are already true RMS with lots of other functions, more than what the Fluke 107 offers. But I will leave it up to you to determine or to decide whether those are worth it, or whether this unit itself is worth your investment or worth your money. Altogether, however, I would say that based on my first impressions and based on the specifications that I read online, the Fluke 107 seemed to deliver on its promise. I'd appreciate your comments and suggestions. Thank you for watching.